Hello and welcome to the TechBrain channel. In this video, I'll be playing with stream processing in MongoDB Atlas. I'll create a stream processing instance. I'll go for the SP30. Currently, stream processing is available in AWS and Azure. I'll select a region, that region there. And I'll call it my stream processing instance. I'll create, and then I'll hit connect. So I'd like to connect via the shell. So that's the command that allows me to connect. I'll fire up my Mongosh. Set up by username. And then what next? Naturally, type help. What information can we get here? So this is available help information. So the first thing I'd like to do is simulate a stream. Your stream processing instance comes pre-configured with a connection to a sample data source called sample stream solar. This source generates a stream of reports from various solar-powered devices. Each report describes the observed wattage and temperature of a single solar device at a specific point in time, as well as that device's maximum wattage. So to verify that the source emits messages, we'll create a stream processor interactively. So I've opened a terminal, and I've actually logged in. So what I'll do from here on is create the stream processor. So the command to create the stream processor is as follows. So it's sp process source, connection name is sample stream solar. So I'm now able to see the data coming through. So these are all the various devices. There is the maximum wattage, as well as the observed watts and temperature. Stream processors that you create with sp.process, like I did, don't persist after you terminate them. So what we want to do is to create a persistent stream processor. So what I'll need to do is to terminate this, and then I'll define my persistent stream processor as follows. I've got a variable here, and I have a connection name for the source. And next is a stage, a group stage. Essentially, I'm creating a pipeline. So that's my pipeline where I'm grouping by group ID. And then I use an accumulator to find the average temperature, likewise, minimum temperature, maximum, and so on. So that's my group stage. The next stage that I need is the so-called tumbling window. It's a tumbling window stage. Why do I need a tumbling window stage? Because I'd like to perform accumulations such as group on the streaming data. So Atlas Stream Processing uses windows to bind the data set. So the $tumbling window stage separates the stream into consecutive 10-second intervals, as we'll see from the definition that I've got here. So that's my tumbling window. So I'm passing in the pipeline at that point. And the next thing I'll do is I'll merge by using a $merge stage. So merge allows me to write what I've processed into my Atlas database. So let's take a look at what we currently have. There is S, and I have the group, and I have my tumbling window. So that's what it looks like so far. And my merge, $merge stage, is the following. Storing it in a variable M. And this is what it's doing. So I need to have a connection called MongoDB 1. So I'll go ahead and create that connection. Before I run this pipeline, let me create that connection. So I'll go here, add a connection. And where am I going to sync this data to? So I'm going to, well, you've got a number of choices here. For this demo, it's going to go to an Atlas database. And I'm going to call this connection MongoDB 1 as per my earlier configuration. So MongoDB 1, and which Atlas cluster, that one there, and execute as Atlas admin, and then connect. Add connection rather, so that's my connection. So this connection is what I'm referencing over here. So in case you're wondering, where's that coming from? That's my connection. So I will package everything up into the following command that creates the stream processor. So it says sb.create stream processor. The name of the stream processor, that's the name of the stream processor, and that's a pipeline. So as you can see, I already have variables for S, T, and M. Those are just some of the stages in that pipeline. Okay, so I'll press enter. That creates the stream processor. So to start it, I'll do sp solar demo start. So we've got that running. So we get back something that confirms that it's actually executed. So we can verify the output of the stream processor by getting the statistics. So it's going to be sp solar demo stats. And if I look through here, I can see information about the name of the stream processor and anything else that's of interest here, the pipeline that I had defined earlier. So next up, I can go to the Data Explorer and see this data that's been aggregated for me nicely, because that was the whole point of running that pipeline. So I'll head over here, clusters, browse collections, and I've got my Solar DB, so I'll minimize that. I've got my Solar DB, and here I've got, for the various 10-second windows, little reports that for each device, they give me the data that I want, or the accumulations or aggregations. If I need to sample any of the data in the stream, I can easily do that. So I'll use that command there. So that's the data in my stream. These are the results of running the aggregation pipeline across that stream. So I'm able to process that in real time, which is great for this kind of application. So you're not batching stuff, no, you're actually processing the data as it comes, being able to run these computations across the data. I can clean up after the end of this demo. $demo and then do a drop. sp.list stream processors, nothing should be coming back after doing that drop. So that is stream processing in Atlas. You have a continuous stream of data that you can process on the fly. And as you saw, you could have this data being saved to an Atlas cluster. Alternatively, you can save the data to Apache Kafka or post it to an endpoint. That's all very doable. Hopefully you enjoyed the video. Please remember to like and subscribe for more great content from the Tech Brain channel. Bye now.